We're going to finish this unit this week. This week. Okay, things we know. When you solve a system, and you guys have already solved systems, you've done this already, you've done it algebraically mostly, so 8.2 is going to be super easy for you guys. We probably haven't looked at it graphically yet. I know we haven't looked at it graphically. Do you guys remember the invariant points? Yeah, what are the invariant points? Do you guys remember? They're the same on each graph, right? They don't move. So similarly, Rory, Amy, similarly with this, we're looking for where the two graphs intersect. What does intersect mean? Meet. They cross or they meet, and we need the coordinate pair stated for the solution. Okay, so you need that whole coordinate pair where they meet as the solution for this. So you're going to be doing a bunch of graphing, FYI, for this lesson. So we are going to look at two different types of systems. We're going to look at a linear quadratic. So guess what that's made up of? A line and a parabola, right? So, and then you can also look at a quadratic. Okay. Options. Oh, I think there's one more. Okay, never mind. I'm just going to draw a random parabola. It's pretty great. I know you're all quite jealous. How many solutions would this graph have, or this system have? Two solutions.
So the invariant points are the solution?
We don't refer to them as invariant points because we're not doing anything to the graphs. We're doing the points of intersection. So we're looking where this graph crosses and that graph crosses. The reason why we don't call them invariant points is we called them invariant points when we graphed and then we did the reciprocal of that function. Megan, I didn't throw one of these on your desk, so right there on the bookcase. So we call these invariant points because we did something to this graph to get the next graph. These two are going to be two completely different equations. So that's why we call them points of intersection and not, what did I say, invariant points. Okay, another option. Another beautiful parabola. How many solutions on that one? None. There is, oh no, we wouldn't do it on this one. There's 4 on this one. Okay, sorry, talking to myself. How many solutions there? 1. Okay, exciting stuff. So when you have a linear quadratic, you have 3 different options. No solution, 2 solutions, 1 solution. Similar to how many roots are there. Talked about that way back in chapter 3. Okay, quadratic. How many solutions there? 1. How many solutions there? 2. You guys are so smart. We have to add in a 4th coordinate plane. None? What if they lay right on top of each other?
How many are those? One?
Infinite. Because every point would match. All right. Don't you feel smart? Okay, there you go. I like when we feel smart. Okay, this one you guys are going to draw the picture. 2 divers start their dives at the same time. One diver jumps from a 1 meter springboard and the other one jumps from a 3 meter springboard. Plot a graph to represent the situation with the height above water plotted over the time elapsed. So I don't want you to plot any points or anything like that. I want you to draw me a rough sketch. Go. 2 divers. And they're going to follow a parabolic trajectory. Parabolic. What does that mean? Parabola, right? So graph it for me. Just give me a rough graph. You need 2 divers. One starts at 1 meter. And one starts at 3 meters. And they both start at time 0. I love it. There are not a lot of pencils on the page. All right, okay. Obviously you guys aren't committed to trying it. So all kinds of situations here. It'd be kind of nice if we all had drawn something because we should all see kind of different situations. Maybe this guy. Doesn't go very high. Maybe this guy goes really high. How many solutions would there be here? None. Could we draw a situation where there is one solution?
It's like they land in the same.
They could land in the same spot. So the idea with this example is just that depending on what we have going on, we could have different points of intersections. This one has none, this one has 1. Would there be any situation where they would have infinite?
No.
No, because they have different y-intercepts, right? So they could never have infinite solutions. Could they have 2? Maybe, yeah, they could. So just different situations. You don't have enough information here to say that this is the correct solution or this is the correct solution. But this is a good example for you to actually look at and create a system. And we're doing it by pretty pictures this lesson. Okay. Solve the system graphically and verify your solution. So step 1, we have to graph everything. I'm going to rearrange all my equations so that they're equal to y, just because that makes more sense to me. What's the most important point on a parabola? Your vertex, right? Because when you create your table of values, you need to put that vertex in the middle. So I'm going to rearrange these. So this is going to be x plus 1 equals y. This one's going to be y equals negative x squared plus 6x minus 3. How do you guys feel about that? Everybody good with the rearranging that I did? Nope. Nope?
Yes.
Doesn't need to be positive. I'm setting it equal to y. So what do I know about this parabola right away if my x squared is negative?
Opens down.
Opens down. So this has a positive slope. So which way is my line going? Is it going up to the right or down to the right?
Up.
Up to the right. Okay, so there's a couple of things I already know about my graphs. I think this one's going to be pretty easy to graph. My y-intercept is 1. Where's my y-intercept on this graph?
-3.
Negative 3, right? So we know some spots already. but I think I want to do a table of values for this one. So I'm going to find my vertex. So x equals negative b divided by 2a. So if I substitute it in, so my vertex is at 3, 6. All right, thoughts, feelings? Good? Are you guys able to create the table of values? This is actually good practice for your chapter 3 stuff, your chapter 4 questions. Okay, what would 4 be? Because we're going to pick values to the right and to the left. I'm going to throw 0 in there because we already know what that would be. Okay, do some math, guys. It's Wednesday. We made it to Wednesday. We have 8 classes, including today, left together. Wow. I know. And we know if our graph opens down, that's the highest point. That's the highest point. So we anticipate that all of our other values should be less than that. What do we know about a parabola? What makes it beautiful?
Symmetrical.
It's symmetrical. So if we know this one's 1 away from the vertex on this side and it's 5, if we're 1 away from the vertex on the other side, we should anticipate that that is 5 too. What do I think 1 should be? 2. It's how much you trust your math. I don't know, I might calculate them all out. That's just who I am as a person. Okay, we're gonna graph our parabola. I noticed that you guys are getting a little bit, I'm not gonna say lazy. You guys are forgetting to, label your increments. Just trying to look for a reasonable pen. Label your increments on your axis, and you need to make sure that they accommodate both this one and this table of values as well. So my highest is 6, so if I went up by 1, if I went up by 2, 1, 2, 3, 5, that's not going to work, so I'm going to go up by 1. So that'd be 2, 4, 6, 8, 10. I'm noticing on some of the tests and stuff like that that you're missing your increments. You're missing labeling 2 points. Those are things that will reduce your marks, and not because you're not smart, but just because we're not paying attention to details. Do you want to go up by 1s on this one?
Yeah.
Okay, we can go up by 1. We're going to connect that with a smooth curve. So this is just chapter 3. Chapter 3 just happening there. And because we have 2 graphs on the same coordinate plane, we have to label it with its equation. You don't want me to get confused.
Do we have to use the original one?
You could use the original one, the rearranged one's fine too. It's whatever you prefer. I usually go with the original, that is a good point. Okay, now we're gonna graph this one. So, when I'm graphing a linear equation, I'm gonna start with my y-intercept, which is at 1. And then my slope is 1 over 1, so I'm going up 1, 1 to the right. I'm gonna go up 1, 1 to the right, up 1, 1 to the right. All right, and we should get a linear equation happening there. How many solutions does this graph have? 2. Okay. So those points are shared by both graphs. I need to label 2 points on each graph. I will. Yeah, you are correct. So I'm going to work smarter, not harder. And these points are shared by both the graphs. So I can just write them once. So this is 1 and 2.
Why did you put 2 to the right?
Because these were done in increments, right?
Yeah.
So I'm going 1 unit to the right and on my x-axis. And that kind of messes me up. I have to think about that a little bit more. So even though I would have had a squishier graph, it might have been better to, I'm at 4 and 5. It might have been better to do increments of 1, just to keep my head straight. Okay, this, you guys are gonna do a test for this. The solutions must be stated as coordinate pairs. You can't just label them on the graph. You have to state that the solutions are, and then list them as a coordinate pair. Video evidence that I've told you this. Okay? What? You have to list your solutions. You can't just label them on the graph. Video evidence. All right, that was pretty easy. Nice thing about graphing is I'm going to give you reasonable numbers. I'm going to give you nice numbers where they cross.
Is there any math that we can do to find out where they meet?
Mm-hmm. That's Friday's lesson. But once you, if you give me a choice on what I could do, graph it or algebraically solve it, I'm going to algebraically solve it every time because I don't have time to graph. That's just silly. Okay, you guys are going to graph. You guys are going to find the vertex of the first one and the table of values. I'm going to find the vertex and the table of values for the second one.
You're going to find vertex?
You guys are going to do the vertex and table of values for the first one. I'm going to do vertex and table of values for the second one. Go. Do the math. Can you guys give me the vertex for the second one? Oh, the first one? I did the second one, you're right. 4-3, everybody get 4-3? Okay, so we all know where we're starting. The points look super similar, but they're not. Because this y is 11, but it's at an x value of 2. This y is 11, but it's at an x value of 0. So it's not an infinite solution problem, but okay. Increments? Ones. Do the same as we did last time. Why won't 6 fit? Oh, if we do the exact same as last time. Yeah, so let's go by 1 tick per increment there. So 6 will fit on this one if we change our x. We can miss that point too, as long as we're on track to get to 11. Like it looks like it. We could plot that point up there. I'm just afraid if we go even smaller, it's going to be like really squished together and hard to see. Okay, I'm going to graph the second equation in blue. I'm going to graph the second equation in blue and the first equation in red. So do what you will with that piece of information. Do you guys always start at your vertex when you're graphing? And it would be 2, 11 would be somewhere up here, 6. So that one is y equals 2x squared minus 16x plus 35. All right, so my increments are done. How many, oh, I'll let you guys finish graphing, sorry. Oops, I don't know what I did there. Okay. Looking at those two graphs, how many solutions do I have? I have one. I have one happening right there. But, so I can label that point for sure, but I need to label 2 points on each graph. I'm probably not going to label that point just because of the location of it. I think it'll just be too crammed in there. So I'm just going to label things on the outside. I know that's at 4, 3, and I know this one is at 5 and 5. And then I'm going to label 2 on my, so that's 2 and 3, and this one is 5 and 1. So I've labeled my 2 points. Vishwa, what do I have to do now to get full marks?
1 and 5. 5 and 1. 1 and 5.
1 and 5. Jeez Louise, thanks. Vishwa, after I've fixed that, now what do I need to do to get full marks?
Write your solution.
Write my solution. I was not getting full marks there. What's my solution?
2, 3 and 5.
3 and 5. And you see that point shared in the table of values, right? Like, so it's there already. So definitely a question on the test doing this. I might ask you to create 2 equations of a quadratic or a linear quadratic that has 1 solution. You'd have to create a system that works. I'd graph them first and then create the equations of them. That's what I would do. Because you know what it looks like. And once you have a graph, you know how to create an equation of a parabola, right? Yeah? Kind of, sort of, okay. So those might be questions, but you do need to know how to graph. It's good practice for the chapter 3, 4, 7, 6 units. Okay, that's it, that's all. That's lesson 1. You guys are done.